All right, so let's add some color to this sim now. Much of the time, when we're doing simulation work with smoke, smoke is all one color, in production. So it's like it's steam, or it's literally black smoke, or anything like that. Even in times where the smoke needs to be one color, like let's say the smoke indicating the landing zone for a helicopter might be green, we can still just render it as gray, and then the compositors can just tint it green later to whatever exact color they need. Sometimes, though, we want color in the simulation because there's multiple colors, and then you can't just tint the whole thing one color. So you can imagine an explosion, a dirt explosion on the ground, for example. Like if this was a dirt explosion, you might have some gray rock stuff coming up here. You might have brown stuff coming up here from dirt. You might have some random lighter color ones that are actually from the explosive charge itself. So having smoke hits that are multiple colors is a really great way to make your work look more professional, as opposed to it just being brown or just being gray. So that's a really nice way to do that. Any reference you look up online of the ground exploding, you'll see that. You'll see that mix of dirt, rock, and the actual gas, the burn from the explosion itself. Other times we use color for these kind of magical or psychedelic looking smokes where you just have different color chalkiness, reds, blues, pinks, cool graphic looking things like that. And that's a more extreme example, and that's what we're going to do right now. It used to be a little harder. You always could do this, but it's gotten easier, and it seems to be pretty in demand. So I figured let's talk about it. So in order to do that, let us go back to our points. The points are just points, but let's start by giving the points themselves color. So I'll drop a color sop down. Lots of different ways you can make a random color, but this one's called color, so why not just go with this? So the color type will be random from an attribute. The attribute will be the ID. The ID is an attribute that particle sims output that even as particles come and go, the particle numbers are being renumbered all the time. The ID is a constant number that is the order that the particle was emitted in. So right now we have 4 particles in the sim, 0 to 3, but as the early particles die, you can see their point numbers are always changing, but their IDs never do. So that's a constant attribute we can base a random color from. So you can see the result pretty easily. They have a color and they stay that color. So that's cool. That is the CD attribute. Let us now make a volume out of that. So take not the velocity one, but take the original density one, copy that one, and say instead of the density attribute, use a CD attribute. So once again, we have this look where it's like, well, why doesn't it just look like the color? Because Houdini doesn't know to do that by default. Simply merge it in here, and the volume visualization, we can say, well, the density field is still the density, but the diffuse field, which is color, is the color one. And look at that. Cool. So this is still everything. This is still the velocity. It's still the density. And now it knows to colorize it, at least in our viewport, by that. That doesn't help our sim specifically, not yet, but it's a step in the right direction. So the simulation itself, if we look at it, we source things from the volume source. Is it sourcing CD in? No, it's not. We need to tell it to do that. So press the plus button here, and it creates a new blank one of these down here. It is a vector because it's R, G, and B. So the source volume is CD. The target field is CD. It will create that. So just by default, we have that. It's not actually right yet, as you'll see, but in any case, we have this here. If we middle click and hold, we do have a CD field now. And if we come look at the result, the DOP import, or the import fields actually does have the CD in there already, so we don't have to add that. And the volume visualizer here, now, look at this, looks a little different. When we were going into the sim, CD was just a VDB that was a vector type. But now on the other side of the sim, they are Houdini sparse volume fields, which don't support vectors. So they actually have to have 3 different volumes, one for each vector component. So now on this side, we'll need to say CD star. So that looks like something, but it's not right, is it? In fact, it's quite wrong. We see these dark areas here. It's too bright. So what's going wrong is the way it's being added into the sim. If we come back to the volume source, we can't just add this in. We need to blend it in, like so. So we say blend it in based on the density amount, and the target is based on this alpha field. So now, if we run it, we still don't see it in the sim, but now on the outside it looks right. Like so. Whee! There's still an issue though. As much as we would like this to be correct. If I were not to do this visualizer, look how much wider the density is here. But when I do this, it looks insane. It just looks like as these thin tubes that never get any wider. And that's because in order for the density is still here. It's still correct. Obviously, if I turn the visualizer off, we know that it's there. But now once we're saying you have to color this by the color has to exist in that area, but it doesn't. The reason why it doesn't is because it's literally not being simmed. It's only being added to the simulation. It's not simming it though. What does that mean? It means it's not advecting it. It's not being moved by the velocity. That's why it just looks like a tube that doesn't ever expand. It's sourcing it all the time, so it's literally sourcing, but they're not, I mean, I think you get it. The edges, as you can see, are static. They're not moving. We can even take this one step further and just say, on the visualizer, the density field can just be that. And this is what's happening. It's just sourcing all these things in. In fact, we see errors happening over here. There's kind of a clue to what's going on, which I pretty much said a few times, which is, it actually looks pretty cool. Looks like a toy. But it's not simulating it. So coming back into here, we need to say on the pyrosolver, it seems like this should be a default, another default that it's missing, but it's not resizing all that stuff we talked about with the sparse simulation stuff, like where this is resizing the active field. It's not doing it for the color and alpha fields. And not only that, as I said, that takes care of that error where you saw it drag to the side. It's not advecting it either. So again, we need to actually put it in here and say those two fields do that. And now finally, and let me make sure this goes back to where it used to be, density. Oh, temperature. There we go. Now it works. Because now the color that is being sourced in is being moved in the same way that the density is being moved. And that's the key. There's actually more color around these areas. Like if we were to come back here again and say, show me, you can see it's actually a little bit bigger. Shouldn't be much bigger because it's being modulated by the density on the way in. But in any case, now it's actually being considered by the sim. It's actually being moved by the velocity fields. So there you go. Now we actually have the color moving. And now we actually have CD fields that the Pyro shader will respect. As we start to move into the rest of this lesson and we talk about rendering stuff, keep in mind that, and I will probably reiterate this in the next chapter, but keep in mind that this is specific to how the Mantra Pyro shader is being done. People are using Redshift now and stuff, or Karma. You know, you might have to adjust what those shaders are doing to actually see this. But whatever your shader, whether you're using Arnold or whatever the shader wants for color, just make sure it's pointing it to these CD fields. These are where the color is stored. The Pyro shader is being developed with Pyro, already knows to look at the CD field. So just keep that in mind in order to see the color. It's being stored in the color diffuse, which is what this is saying. Great. Cool. And moving on to one last thing, which is to just make it higher res and such.